Well, thank you. Welcome to Gradual Typing for Ruby. Today we're going to compare RBS Tip and RBI Sorbet. My name is Alexandre Terrasa, and I'm a staff engineer at Shopify. I work in the Ruby on Rails infrastructure team with all those amazing people. You may have heard some of the projects we're working on, such as Truffle Ruby, YJIT, Syntax Tree, the Ruby Debugger, the Ruby LSP, and many more. But let's go back to our problem, gradual typing for Ruby. First, why do we want to perform type checking? Let's take an example, very simple. We have a cow that has a name, that takes a name as in its constructor, sorry. And we have a method talk that is going to do something with the name and display it. We can have good code where we're going to initialize the cow properly by passing a string for the name and call the the talk method and everything is good. But we can also have like bad code where we pass the wrong argument here to the constructor. And we're going to have a runtime error, something we want to avoid because our customers, for example, may have this error page displayed. We want to avoid these kind of things. Of course, it looks like a simple example. And for example, OpenAI or any language model could be catching these kind of things. But for bigger code bases, it may be harder. And also, it's not all about fighting type errors. If I take this piece of code here, the multiply method, I can pass a string to this method. And I'm going to multiply the string foo by 2 and getting foo. But as a provider of a library, is it actually what I intend the user to do? What I wanted to use types to enforce a contract by telling my users, this is the kind of things you are allowed or not allowed to do with the code I'm providing. And this is something that AI is not ready for. Type checking for Ruby is not a novel thing. Already in December 2015, Jeff Foster from Tufts University, a researcher, released RDL. That was the first way to add types to methods and ensure type checking. Then in June 2019, Stripe released Sorbet, another way to type check Ruby code. For the story, we've been using Sorbet at Shopify since February 2019. And more recently, in December 2020, we had the release of RBS, and Sutaro also released Tip to type check a Ruby program using RBS. So none of this is really new. What came with Ruby 3 was defining the key items for gradual typing for Ruby. So at the first level, we have the Ruby code. It's your application code, but also the code of all the libraries you're using, such as the gems you're using. The idea with Ruby 3 came with defining a type definition language, something that defines what is inside your application code, but also in the gems the code of the gems you're using. And comes the level 1 type checker. This kind of type checking tool, like TypeProf, for example, is going to do type profiling. It's going to use the type definitions from the gems you're using and the application code directly to find type error information, but also to generate type definitions. And we saw in Yusuke's presentation, for example, that TypeProf can infer some of the types in the program and generate the signatures that match for this. A note here is that the type profiler, the level 1 type checking, is not really actually using type definitions for the application code. It uses type definition for the gems, so it doesn't have to parse them and it goes faster. But it's not made, like, it doesn't need type definitions for your application code. It just infers things from the code itself. Then we have level 2 type checking. This is where things such as Tip or Sorbet come into play. And those ones are going to use type definitions for your application code to perform the type checking. So when we talk about RBS or RBI, we are at like the second layer here with the type definition language. When we talk about Tip and Sorbet, we're going to talk about level 2 type checking. The key objectives of the gradual typing for Ruby 3 were to provide one standardized language for type definition, which is RBS. It's easily readable and writable for Ruby programmers. And it's independent from Ruby programs. You do not have the type annotations and the type definitions directly into the code application. It's meant to be pluggable. You come with a type profiler or a type checker that you like that fits your needs. So you can bring type prof, you can be steep, sorbet, or whichever type checker is coming to exist after those few years. And it allows for optional source-level type annotations. So things such as, like, for example, casts are allowed, but they are specified not by Ruby, but by the type checker that you're going to bring in your solution. And those type annotations would depend on the need of the type checker. And it's important to make the distinction between what is the type definition language and what is the type checker. The type definition language, RBS or RBI, defines the type definition syntax, or you're going to write types for your application. And it defines the construct that you can, on which you can put types. The type checker, such as steep or sorbet, performs the actual type checking. It implements the type safety rules that are going to be applied to your program to say this is a type error, this is not a type error. And it also defines the inline type annotations, such as a cast, that it may have to use to perform the type checking. Let's do a very, very fast comparison of steep and sorbet. So they both support gradual typing. That means that you can add types to your program gradually. You don't have to type everything at once. They both support flow typing. You can use things such as like type tests and type cases to refine the types that are going to be used inside the block of the methods. Steep supports structural typing, which is more representative of what duck typing is doing. In Sorbet, we're going to use only nominal types, and we're going to see a difference about this when we're going to talk about interfaces later. They both require inline annotations inside the application code. Steep is going to use RBS to perform the type checking and like to read those type definitions in the RBS format. Sorbet is using another format that we're going to see that is called RBI. Steep is written in Ruby, Sorbet is written in C++, and Sorbet also comes with a runtime type checker component. We're going to see why a bit later. If you want to know more about those two tools, I encourage you to see past RubyKaigi talks here by Sutaro and Jay about Steep and Sorbet. If we look at the syntax of the definition languages, the type definition languages, on the left we have RBS that is coming with like a syntax to define what is the type of an instance variable, of the attribute reader name, of the initializer, of the talk method. And we have the same thing on the right with a different syntax, but representing the same kind of thing. The difference here is RBS is an external domain-specific language for type definitions. The syntax is different from Ruby. When you write RBS, you do not write real Ruby. It's a different language. It's much more expressive because you're not constrained by what is Ruby to actually express the types and the definitions you want to give for your program. One downside is because it's a different language, it's a new language, you need a whole new set of tools, for example, for your IDE to do like the edition. Also here, an example is in GitHub. We don't have yet syntax highlighting for RBS file right now. At the opposite, RBI is using what we call an internal domain-specific language for type definitions. The syntax is Ruby. It is written inside Ruby. It's a bit less expressive because you're constrained to what Ruby allows to define the structures you want. But in exchange, you get all the power of all the Ruby tools that already exist, such as like formatting, rubocops, and etc. And you also have like syntax highlighting for free. Like I said before, they both require annotations inside your Ruby code to work, or to work better. Steep annotations are going to use comments. You can see them at the bottom here, at the end of the line, defining what is for example, the type of the name variable here. Because it's comments, it's not part of the execution. The VM is actually not going to see them when you're executing the program. That means you don't need any dependency to actually understand the annotation that you have in the code. The inline usage is a bit limited because it's only at the end of the line. You cannot like just type a part of an expression. And from an implementer point of view, if you're writing the type checker, you also need to pass comments now. On the on Sorbet side, the annotations we use in the code are actually Ruby code. You can see, for example, here the t.must that says that this thing is not going to be nil. So this code is actually going to be executed. And this is where the runtime component of Sorbet is present. If you see this require Sorbet runtime, it's for Ruby to actually understand what those t.must are and mean. And Sorbet runtime is also going to, at runtime, perform checks for you for things that may not have been checked statically. It has a downside, though, is that now you need this dependency, Sorbet runtime, and that means if you use it in your gem, all the gems that are going to use import, you will have to also import Sorbet runtime. And it has some readability concerns because it doesn't feel like the Ruby we know. So which is the one that works for us at Shopify? Like I said, we started with Sorbet in January 2019. Since then, we've been adopting it in our core monoliths. We have 98% of the files in the core monolith that are already typed. And 61% of the methods we have over many that have signatures right now. If we ask our developers, and we made like different surveys, they actually want more code to be typed. It's bringing them like some confidence, very nice tooling around this. So we've been seeing like almost 80% of the developers we surveyed were agreeing that they want more types inside the core monolith, but also they want more projects to have Sorbet at Shopify. So Shopify developer want types. If we look at the other projects outside of the monolith, even if we've not been pushing for it, we've seen a steady increase of projects at Shopify using Sorbet by themselves. What they're not completely agreeing with is the type definition syntax, so RBI. As we've seen, it doesn't look completely like Ruby, maybe a bit variables. So they agree that even if they want types, they would like to have a better syntax to write them. So first question is like, okay, can we just migrate to RBS? There is Tip that is already understanding RBS. What can we do with this? The first limitation is the type checking speed. If we look at tiny programs, Tip performs almost as good as Sorbet. In a few seconds, you can get the type checking information you want. When we look at a core monolith, when Sorbet can type check in 15 seconds the whole code base we have, it takes around 45 minutes for Tip to perform. That means that we cannot enable it on CI. Getting feedback in the IDE is going to be very cumbersome. So we can't really go this direction here. And it's very hard to fight against an implementation in C++ that has been engineered from the ground up to support like huge code bases. Another problem is the type safety. So the rules applied by the type checker over the code it's type checking. Let's talk very fast about Liskov substitution principle. Here I have an example of code where I have some food. I have meat, that is a kind of food, grass, that is another kind of food, and I have an animal that can eat food. I have this cow that is a kind of animal, and I have a method to feed an animal with some food. In RBS, I can write this. I can say, okay, an animal is generic. It's going to eat different kind of food. And I have this cow that is a more specific animal that is going to eat a more specific kind of food, grass. So I'm writing the type grass here, saying the eat method for the cow is taking a grass. And I'm saying my feed method is taking an animal, something typed as food, and is going to feed this to the animal. And I shouldn't be able to write this because it allows me to write this kind of code. I'm going to be able to call feed a cow.new and meat.new, and I'm making the cow eat meat. So this definition in RBS here should have been rejected to have safe typing. And this is something we really care about at Shopify. So this is another reason we cannot really go directly with Tip at this point. Last reason, because RBS is a separate file, one of the problems with RBS is that we need to duplicate everything. So the thousands of files we have, like with classes and methods and everything, now we need another thousands of RBS files for those type definitions. When in Sorbet, we can actually put those type definitions and type annotations directly into the same code inside the same Ruby code. So that means we do not have to duplicate this. For us, it's more dry. So what will it take for us at Shopify to use RBS? Because we care about, like, we like the syntax, just we kind of like need the speed of Sorbet and the strictness of Sorbet. So we did an experiment. We actually wrote RBS to RBI translator in C++, and we integrated it inside Sorbet. And so we can still pass our Ruby file and RBI files to Sorbet, but we can also pass RBS files to Sorbet. And this translator is going to, on the fly, at type checking time, transform the RBS, translate the RBS into RBI, feed that to Sorbet, and we get the type error information. We actually opened a PR about this, but we closed it. First reason is we have to maintain the C++ RBS to RBI translator. So every time there is a change in RBS, we need to apply the change on the translator, which is kind of like redundant work. And also that means that we have to, every time we run the time checking, we have to retranslate RBS to RBI for all the gems in the application, which is something we could do only once and not do it again. So we changed the way to do this, and the solution here is Tapioca. If you haven't seen this amazing talk from my colleague, Emily, generating RBIs for dynamic mixing with Sorbet and Tapioca previously, I think it was the first day. I invite you to see it, or just like look at the README file of Tapioca. And the idea is to perform RBS translation ahead of time. We're going to feed the RBS files to Tapioca. Tapioca is going to translate them as RBI files. And then at type checking, we're going to feed all those RBI files and the Ruby files of our application to Sorbet to get the type error information. That means that Tapioca can use the official RBS parser, no duplication. And that means we can do the translation only once, no need to redo it for every type checking. So let's see how we can actually translate RBS definition to RBI. So first, RBS and RBI are actually quite similar in terms of features you can use to type your code. You can type instance methods, singleton methods, module function, accessors, instance variable, constant, global variable not directly, interfaces and overloads, no problem. For the global variable, we actually rely on a inside the code type annotation. Let's just take a look at instance variable, for example, here. Like you cannot in RBI directly do this because we don't have a Ruby syntax that is appropriate to do these kind of things. Instead, we do this type definition inside the actual Ruby code by using the t.let and putting the type we want here. So we're not actually directly translating this part here. But that's not a problem. We can still type check, no problem. For interfaces, like I said before, STIP is using structural typing. So we have this kind of interfaces that represent the kind of methods you can call on something. So here I can have an interface called eat grass. This is something that eats some grass. And I can include it in my cow because I want it to eat the grass. With Sorbet, what we're going to do is to create a module that is an interface that is marked as interface, that's going to have this abstract method here and like include it in the cow. So that still works. It's nominal typing. That means we have to we attach a name to this thing, and it's represented as this in a module that is an interface. It's slightly more difficult than this. Like I don't have the time to tell the whole story, but if you're interested in how it works, come to see me after my talk. Another limitation we have is around like overloads. Here we have a method that can take a method name or a block and does different things depending on the arguments you pass. So in RBS, you will represent this such as it's taking either a symbol or a block that is going to take a cow as an argument and then return nothing. One solution could be to try to fit all the overloads together to merge them into one only signature, because this is only what we can support with Sorbet right now. But that becomes very cumbersome when you have like many overloads taking different parameters. So our solution is actually the simple one. We just don't do anything. We just remove the methods from this. Luckily, for most of the gems we use and the application code we don't have that many overloads. So that means we don't end up with too much untyped code at this point. So it's not directly supported. For base types, most of the types are actually present. Slight difference here. Bullish is going to be translated as a T unknown. And the literals, I'm going to show it here. So here I have a cow that has a method call that is calling to send the method you're passing, the method name you're passing as an argument here. So what we want to allow is like you can call car.call talk, but no car.call foo because it doesn't exist in this class. In RBS, you can do something like this. Say like the type of this thing is actually just a symbol and just the symbol talk. Since we can do this with Sorbet, what we're going to do is to just extrapolate what is the type that represents the symbol we have here. So like here we have a symbol talk, so we're just going to accept symbol. It's not as precise, but it's good enough for us. Again, we don't have too many occurrences of these kind of things in the code base. Everything about composite types, so optional types, intersections, unions, we can translate, no problem. For the blocks and procs, we can do almost the same thing. There is one slight difference is when you try to bind the self type of a proc. You can do this in RBS. In RBI, we rely on an inline code type annotation. So you have to do this inside the code itself. Where the problem lies is about generics. So let me tell you a bit more about like generics in RBS and RBI Sorbet. So most of the things that are present in RBS are also present in RBI. Something that I don't think RBS support right now is lower bounds on generics, but this is not where the problem is. For the translation, we're going to be able to do something, but not always. I'm going to explain this. So let's take an example. I have a pen, which is a kind of like this enclosure for like putting cows in it, or like different kind of animals. So this pen has an internal array of animals, and it has this accumulator method in which I can pass an animal and it's going to put it in the pen. And I have different animals. I'm having like a cow and a wolf. And ideally, I will be able to not put a wolf in the middle of many cows because it kind of causes problem. So in RBS, I can represent this class as a generic. So I'm going to use the syntax where I have the bracket notation, and I'm going to say like pen is going to take a type parameter that is t. And the accumulator method is going to use the same type that was declared when you instantiate the t. And to instantiate this class as a generic, you're going to do pen.new, and then you're going to pass this type annotation here. Pen is actually a pen of cow. So if you try to put a wolf in this pen, it's going to be rejected by STIP. In Sorbet, it's a bit different. You actually, in your Ruby code, you have to extend t-generic that is going to do some magic that I'm going to show. And you define a constant, lm here, that is the equivalent of for t in the other representation, that is going to be the type member of the thing. And we can use the constant as like the constant we use for the type of the accumulator. Extending t-generic gives us this magic thing here that in our application code, we can actually pass directly the bracket to pass the type parameter for our pen. So now, no pen of cow, we can do pen of cow.new, and we have a pen of cow, and if we try to put a wolf into it, it's rejected. So both of them support generics. Both of them also support generic bounds, where I can say, okay, my pen is actually specialized to just animals, and the thing you can do is just pass me a subtype of animal to create a pen. So with RBS and STIP, you can do this, pen.new, say this is a pen of cow, and when you write pen.new and this is a pen of string, it should be rejected. It's actually not rejected right now by STIP, but this thing should be rejected, and we can fix this. In RBI is the same. We can set an upper bound to the type member, saying this is an upper bound to animal, and so when we try to do pen of string.new, it's getting rejected by Sorbet. Now a bit harder. We're going to fix the generic type of our pen. So we're going to create a class that is a cow pen that is only accepting pen, or cows, sorry. So the super type of this thing is a pen of the generic type cow. That means that when we create a cow pen.new and we try to put a wolf into it, it's automatically rejected. This works in RBS and STIP. This also works with the fixed here annotation on the type member on Sorbet and with RBI. Now the problem. We can have different interfaces that have different type members, and we can have a class that imports those two interfaces, includes those two interfaces, saying like for I1, the type member is going to be an integer, and for I2, the type member is going to be a string. The problem is in Sorbet, because of the syntax that is used, if by an unlucky chain of events, you use the actual same name for the type member, so in I1, I'm using the type member and saying it's called LM, and in I2, I'm using the same name, I'm actually not able to redefine the type of this type member in the class C. Because LM, I will be just redefining the constant, and I'm still just defining one of the type members, not two of them. So I can't actually represent the same thing. There are solutions, though. We could go and rewrite everything to like prefix the name of the type member by the class, the name of the class. That's kind of quite a lot of work, and we've been lazy at this point. We decided to go with a much easier approach. We're going to just fix the type to untyped and say, okay, we know it's a generic, but in this very kind of obscure case that is not happening that often, we're just going to say, okay, we're going to relax the generic constraint and let you do whatever you want. This is still gradual typing. So we can translate the generics, but in this case, we're going to just relax it. In the other cases, it's working. This leads us to ask ourselves, is there like some features that in RBS do not exist but exist in RBI and may be super useful for what we're doing? One of them is about abstract classes. So the most convenient way before type checking in Ruby to define an abstract class is to just raise in the initializer. One of the problems is that it's breaking the encapsulation. I would like for this animal class to initialize its own @name instance variable and not leave that to the subclasses. The encapsulation tells us, oh, it should be done in the animal class, not in the cow class. The problem is in the cow class, I cannot call super and let the instance variable for animal be initialized because I will get this raise. So that's not a very good design, and we can do better. Actually, Sorbet comes with a feature that is called abstract. You can say that your class is abstract ! And it's going to mark it as abstract. You can still do your encapsulation properly and initialize the @name variable locally in the animal class. And you can still call super in the cow class. But if you try to do animal.new, you're going to get a static error telling you this class is abstract. You shouldn't be doing this. And it's the same thing for abstract methods. We could raise in the talk method here in the animal, saying like, oh, this is not implemented, this is abstract, you shouldn't be calling it directly. But if you forget to implement the override and provide the implementation in the cow method, if you call this, you're going to get a runtime error. While a type checker could help us here. If we look at Sorbet, for example, we can mark this method as abstract, and if we forget to implement the talk method in cow, the static type checker is going to tell you like, well, maybe you forgot something here, and you're not going to have a runtime error. Another feature that we added to Sorbet that is super useful, especially when you use Rails, is how to require ancestors for mixins. So I'm having still my animal, and I'm having this talkative animal that is a module, a mixin, that is going to provide the talk method. So the right way to use it is I'm having a cow here, and I can include talkative animal because I need the instance variable of @name here. I can include it in my animal. Problem is, there is nothing providing me to actually include this talkative animal in my class grass, and now I'm having a problem. With Sorbet, what we can do is to say, talkative animal requires an ancestor that is an animal. That means I can only include it in something that is an animal. So if I'm trying to include it in grass, the static type checker is going to tell me, well, if you want to include talkative animal, you must inherit from animal. And that avoids more error, especially when you use Rails. Another kind of features, maybe delegation, representing things such as, like, I'm going to delegate this method to this other class, or I'm going to use method missing, and maybe enums could be also very useful. Going further. So if you saw Yusuke talk, you notice that something that is apparently very useful is to have the type annotations and the type definitions and the signatures inside your application code. There is actually now a feature in TypeRough to do that. So we were thinking about those two options. Either you can have it as Ruby code, and you have, like, for example, ivar, sig, and you pass the RBS definition directly to this. The problem is that to understand those ivar and sig method calls, you will still need like a dependency on something like Sorbet runtime. So instead, I feel that Yusuke's proposal to use the comments directly like this is very powerful, and it's dry enough for us. We can use this. Now comes the question of inline type annotations. What do we do with tmusts, the casts, using let to define the type of a variable? So there are like many ideas. We can still use what Sorbet is doing, t.must. We can use what Steep is doing using comments. Or we could like look at something a bit more expressive and using, for example, .as and passing the type here, or saying like, oh, this is not going to be nil, but I don't want to repeat the type because it's a long one. I can say like .as not nil, or like just .as not nil as like one function. So this can be provided as a gem, and you have your method here, but that means, again, we need to require this kind of like better type annotation gem, providing as not nil, and everything. Or that could be a Ruby feature. We have many type checkers. It's going to be there for a while. So why not having some of the primitives and the very core things we need to type check and to write type annotations defined in the code? So if you notice here, this method .as is actually not doing anything. It's just returning self. But it's something the type checkers, such as Steep or Sorbet, can anchor in and provide the type checking and perform the type checking they want without actually polluting too much the Ruby code. And as if we wait more, we're going to have many, many, many of these type annotations being created for the many, many type checkers that are going to be created for Ruby. And it's going to be harder and harder to actually simplify this at some point. So maybe we could have some suggestion of like very core methods we could add and use them here. So there is a proposal right now on the issue tracker from Jake that is working at Stripe on Sorbet to add one method about like casting things at not nil, but we could be proposing other things. Some takeaways here. So RBS is going to be the de facto future of type definition for Ruby. This is how we're going to write the signatures. Implementing type checkers for Ruby is very hard. There are a lot of things we need to take in account for. Using RBS with Sorbet is possible. There is a path for that. And it's possible to some extent already right now. Generics are kind of a big issue if you start using a lot of different superclasses and interfaces. Some feature may be missing to RBS. I'm thinking notably abstract classes, methods, require ancestors around delegation. And I think we still need a solution for inline type annotation and inline type definitions. UCK provided one with typeprof. We still need a solution for type annotations when it's not just the signatures. Type checkers bring their own solution, but maybe we can provide something that is a bit more standardized for very few core features. Thank you very much.